Why are so many kids, and let's be honest, so many of us, completely stumped by fractions? For decades, the go-to answer has been this idea that there's a kind of glitch in our brains. But is that really what's going on? Today, we're going to tear that idea apart and see what's really happening.
So, this is the big question, right? Is there something fundamentally wrong with our wiring that makes fractions so hard? The official story says yes, that our brains are built for whole numbers and fractions are just unnatural. But what if that whole story is a myth?
Okay, to really get this, we have to start with the official story. It's the theory that has dominated education research for years, and it's got a very official sounding name, the natural number bias. And listen to how they talk about it. Researchers call it a fundamental cognitive obstacle. I mean, that's not just a small hurdle, right? That phrase makes it sound like this massive, unavoidable wall that's built right into our biology. It gives the whole theory a ton of authority.
So, what exactly is this natural number bias, or NNB? Well, the theory goes something like this. When we're little, we learn some basic rules. 4 is bigger than 3. Multiplying makes things bigger. Adding makes things bigger. Simple stuff. This knowledge gets baked into our brains, becoming our cognitive default setting. So later, when a teacher introduces fractions, our brain's default programming starts flashing error messages, and we have to actively fight our own instincts to understand.
And let's be super clear, the mistakes they're talking about are absolutely real. Kids make these errors all the time. We've all seen it, right? A student thinks that a quarter of a pie has to be bigger than a third because, well, 4 is bigger than 3. The errors are real. The big question is, what's causing them? And this, right here, is where the whole official story starts to unravel. Let's just zoom in on that one classic error, the idea that multiplication always makes things bigger, to see what's really going on. And boom, here's the smoking gun. Think back to how you were taught multiplication. It was probably repeated addition. 3 times 15 just means you add 15 to itself 3 times. Simple. And with whole numbers, this model works perfectly. And yes, it always makes the number bigger. But with fractions, you need a totally different way of thinking about it. 3/4 of 60. It's about taking a part of something. And when you do that, the number can get smaller. The problem isn't the student's brain, it's that we teach them a model that's destined to fail them later on.
So this is the big reveal. The student's faulty intuition isn't some natural inborn glitch. It's a direct result of what they were taught. These aren't natural mistakes. They are, in fact, manufactured. They're an outcome of an incomplete and flawed way of teaching.
Just calling this thing a bias might not seem like a big deal, but it has massive consequences. That one little word completely changes where we look for a solution. It shifts the blame. See, if you believe it's a cognitive bias, then the question you're forced to ask is this one. The problem is seen as being inside the student's head. The burden is entirely on them to rewire their own brain. The teaching is fine, you see. It's the student's brain that's the problem. But if you throw out that whole bias idea, the question flips completely. It becomes this. Suddenly, the focus is not on a faulty student, but on a faulty system. It makes you wonder, why is our teaching so incredibly good at producing the exact same error in millions of kids year after year? And that's the real poison of the bias diagnosis. It takes a teaching problem and cleverly rebrands it as a learning problem. The whole investigation moves from the classroom, where we could actually fix things, into a cognitive science lab where the student's brain gets poked and prodded. And just like that, the system is off the hook. So you have to ask, if the evidence for this bias is so shaky, why on earth is it so popular? Why does it stick around? Well, the answer has a lot less to do with science and a lot more to do with just how convenient it is for the institution. So why is it so convenient? Well, first, it lets the education system completely off the hook. If kids are failing math because of a universal brain glitch, then it's not the system's fault, right? It's just nature. Second, it gives a perfect excuse to do nothing. Why bother with the hard work of curriculum reform if the problem is just hardwired into kids' brains? And third, it becomes a scientific-sounding excuse for why some kids get math and others don't. And that's really the ugliest part of all of this. The NMB theory is basically a modern lab coat-wearing version of the old, tired idea of the math person. The belief that you're either born with a math brain or you aren't. It suggests that success comes from some innate ability to fight your own instincts, not from getting great teaching. It makes failure seem natural. Okay, so let's bring it all home. What's the final verdict here? I think it's clear we need a radical reframing of this entire issue. We need to ditch the word bias and replace it with something much, much more accurate.
And this is the most important idea to take away. What we've been calling a cognitive bias is really a cognitive scar. Think about it. A bias is supposedly something natural, something innate. But a scar is acquired. It's evidence of a past injury. A bias is the student's problem. A scar is the system's problem. It's not some natural obstacle, it's the scar tissue left behind by bad instruction.
So here's the bottom line. Our frantic focus on trying to fix students, to help them overcome their supposed brain glitch, is totally pointed in the wrong direction. The real emergency, the real urgent task, is to fix the teaching that creates these scars in the first place. And that leaves us with one last, pretty provocative question to chew on. If this widely accepted bias is really just a teaching failure in disguise, it has to make you wonder, how many other so-called learning disabilities are actually teaching disabilities? How many other problems are we blaming on our kids when we should be looking right back at ourselves?